In 2025, the United States government quietly blacklisted 140 Chinese companies in a single week. Not for espionage, not for sanctions violations, for making chips. Specifically, for making chips that Washington decided were too good. That list included companies most Americans have never heard of, but in Beijing, those names are printed on billboards. The Chinese government responded by pouring an additional $47 billion into its domestic semiconductor fund, the third such infusion in under a decade. The question everyone is asking behind closed doors in Washington, in Taipei, and in the boardrooms of ASML and TSMC is this: is the embargo actually working, or are we already too late? Here is why the answer matters beyond geopolitics. Semiconductors are not a niche industry. They are the physical substrate of the global economy. Every electric vehicle, every hospital ventilator, every fighter jet, every smartphone, every data center running the AI models that are beginning to reshape entire professions, all of it runs on chips. The United States imports roughly $500 billion worth of goods annually that depend on semiconductors manufactured in Asia. If that supply chain fractures, not hypothetically, but the way it fractured briefly during COVID when a chip shortage wiped out $210 billion from the auto industry in a single year, the consequences are immediate and physical. Your car does not get built. Your hospital equipment does not ship. The defense contractor building missile defense systems for Ukraine and the Middle East cannot fulfill its contracts. The Patriot interceptor system currently being stretched thin across 3 active conflict zones relies on chips fabricated in Taiwan. That is not an abstraction. That is a logistics crisis waiting for a single bad decision to trigger it. To understand how we got here, you need to go back to 1990. At that point, the United States produced roughly 37% of the world's semiconductors. American companies like Intel, Texas Instruments, and Motorola were the industry. Over the following 3 decades, a rational economic decision was made repeatedly by executives and policymakers alike. Let Asia manufacture cheaply, and let American companies focus on design. It seemed brilliant. Costs dropped. Margins expanded. The iPhone became possible. But the analogy is something like outsourcing the foundation of your house to save money on construction. It works fine until there is an earthquake. China watched this dynamic for 30 years and drew a precise conclusion. Whoever controls chip fabrication controls the future. In 2015, Beijing launched Made in China 2025, a state-directed industrial strategy explicitly targeting semiconductor self-sufficiency. It identified chips as the single most critical choke point in the global technology supply chain. Washington barely noticed. By the time the Trump administration began restricting Huawei's access to American chip technology in 2019, China had already spent years studying exactly how dependent it was and exactly what it needed to fix. What most people do not know is that the critical battle is not really about the chips themselves. It is about one machine. The extreme ultraviolet lithography machine, built exclusively by a Dutch company called ASML, is the only tool in the world capable of printing the circuit patterns needed for chips at 5 nanometers and below. There is no second source, no Chinese alternative, no American alternative. ASML's most advanced EUV system costs $380 million per unit, weighs 180 tons, contains 100,000 individual parts sourced from 5,000 suppliers across 24 countries, and requires a team of ASML engineers on site to keep running. The United States has successfully pressured the Dutch government to ban all EUV exports to China. 0 machines have shipped to China since 2023. This is the most consequential export control in modern industrial history. Without EUV, China cannot fabricate leading-edge chips using conventional methods. It is the equivalent of trying to build a Formula One engine without the ability to mill tolerances below 1 millimeter. You can build something, but not that. And the gap between what you can build and what the frontier requires is, for now, enormous. Here is where the story turns. China may be building a way around the wall. In September 2023, Huawei released a smartphone containing a 7-nanometer chip, the Kirin 9000S, fabricated entirely within China by a company called SMIC, without EUV, using older deep ultraviolet lithography machines stacked in a process called multi-patterning. Semiconductor analysts at Tech Insights tore the phone apart within days. Their conclusion was blunt. This should not have been possible. SMIC achieved 7-nanometer class density using equipment that the industry consensus said could not do it. The yield rates are low, estimated around 20%, meaning 4 out of every 5 chips produced are defective and discarded, compared to TSMC's yield rates above 80%. That makes each chip expensive and slow to produce at scale. But the 2023 Huawei phone proved that China can reach advanced nodes without the machine everyone assumed was the absolute barrier. That changes the strategic calculus in ways that Washington is still processing. If the wall can be climbed at 7 nanometers, the question becomes how long before multi-patterning innovations push that to 5, to 3, to levels that matter for military AI systems. The mechanism behind why chip size matters so much is worth understanding directly. A nanometer is 1/1,000,000th of a meter. Human hair is roughly 80,000 nanometers wide. When engineers talk about a 3-nanometer chip, they mean the transistors etched onto that chip have features approaching that scale. A modern chip contains as many as 100 billion transistors packed into a space the size of your thumbnail. The reason shrinking matters is twofold. Smaller transistors switch faster and consume less power, which means more computation per watt. In AI training, power consumption is the binding constraint. Running a large language model at scale costs tens of millions of dollars in electricity per month. A chip that delivers 40% better performance per watt does not just save money. It determines which countries' AI systems can train larger models faster and at lower cost. Think of it like this. Transistors are to processors what neurons are to a brain. More neurons, packed more tightly, firing more efficiently. That is the difference between a system that can reason and one that cannot. The country that manufactures the most advanced chips is therefore not just winning a trade war. It is determining whose artificial intelligence leads the world by the end of this decade. The complications are real, and they cut in multiple directions. First, the American strategy of restricting China may be inadvertently accelerating Chinese self-sufficiency. Every export control makes domestic Chinese chip development a national survival priority, flooding the sector with talent, capital, and political will that it would not otherwise attract. CXMT, a Chinese memory chip company virtually unknown outside the industry 2 years ago, now produces DRAM chips at specifications close to Samsung and Micron. Second, the embargo creates serious collateral damage for American companies. NVIDIA lost access to its largest overseas customer overnight when the H100 export ban took effect. Applied Materials, Lam Research, and KLA, the 3 American companies that dominate semiconductor manufacturing equipment, derived between 25 and 35% of their revenue from China before the restrictions. That revenue is now gone. Restructuring is ongoing, and competitors in Japan and South Korea are quietly filling the vacuum. The policy is strategically coherent but economically painful, and the pain is not evenly distributed. For you personally, this war has already changed what you pay for technology and what jobs are growing fastest in the Western economy. The CHIPS Act committed $52 billion to rebuild American semiconductor manufacturing, and that money is now building fabs in Arizona, Ohio, and Texas. TSMC's Arizona plant began producing 4-nanometer chips in late 2024. Those fabs need process engineers, materials scientists, and supply chain specialists, fields now commanding salaries 30 to 40% above the broader tech sector average. If you work in manufacturing, advanced materials, or defense contracting, this is the most important industry shift of the next decade for your career. If you work in software or AI, the chips your models run on are about to become more expensive if the Taiwan supply chain is ever disrupted. Watch the price trajectory of cloud compute costs. That number will tell you, before any news headline does, how the hardware war is actually going. Here is where this ends up. The United States holds the high ground today, controlling EUV access, leading at the 3-nanometer frontier, and housing every major AI chip designer from NVIDIA to AMD to Google's custom silicon teams. China is producing advanced